Okay, today we're going to do number 7 on the mechanical energy practice worksheet. This one's a little bit different than some of the other ones that you've done, so I just want to give you that as an example as well. This problem is about a roller coaster that has a vertical drop of 68.6. A picture is always a good thing, so this is 68.6 meters. It says the roller coaster is designed to have a speed at the end of the drop of 35.6 meters per second. Assume the cars are at rest at the start, so velocity at the top is 0. And the question is, what percent of the mechanical energy at the top, or in the initial mechanical energy, is dissipated by friction? So there is friction throughout the whole drop, and we're supposed to find the percent of the energy at the top that goes to friction. If there was not friction, 100% of the energy at the top would be equal to 100% of the energy at the bottom. But with some friction, some of that energy is lost. So a little analysis before we start the problem. At the top, I only have potential energy. There is no kinetic energy at the top. Without friction, I would have all kinetic energy at the bottom. There is no potential energy at the bottom, regardless of friction. So what I'm going to do is start by just thinking about how much energy would I have at the bottom if I did not have friction. I can find that by setting the total energy at the top, which is potential energy, equal to the kinetic energy at the bottom. Remember, this is without friction. Okay? Mathematically speaking, potential energy can be written as mass times gravity times height. Kinetic energy is 1/2 mv squared. Remember, this is at the bottom and the potential is at the top. The mass of the roller coaster is not changing throughout the flight or the slide, so if I divide both sides by mass, the mass of the roller coaster will reduce out. Gravity is 9.81. The height of the coaster is 68.6 meters. Make sure you're in SI units always. 1/2. What would the velocity at the bottom be without friction? When I solve this, I get velocity equal to 36.6869 meters per second. That is without any loss of energy from friction. The actual velocity at the bottom is 35.6, which makes sense because the velocity should be less than the velocity without friction, because some of the energy went into the heat instead of going into the speed at the bottom. The question is the mechanical energy dissipated. Well, the energy is kinetic energy at the bottom, so we can't just look at velocity, we have to look at the kinetic energy, which is 1/2 mv squared. For both objects, the mass is the same, so we won't look at that. We don't have to take the mass into account. So the kinetic energy without the friction would just be 1/2. We'll look at the v squared, which is the 36.68. And when I calculate that, I get 672.966. That would be joules of energy, but that's not the actual number because I disregarded mass. Then I can look at what the kinetic energy would be with friction. So I have to use the velocity. At the bottom, which is 1/2 35.6 squared. And when I solve that, I get 633.68. It could be in joules, but again, this isn't the actual number because mass is not being taken into account. This makes sense because this number should be smaller. Some of the energy went into the friction instead of into the kinetic energy at the bottom. If I want to find a percent difference, I want to take the difference between these two numbers, the 672.966 minus the 633. Remember, absolute value. I'm running out of room. Divided by what I should have had, which is the 672.966. You multiply that times 100%, and you will get 5.8% lost due to friction. Good luck on the rest of the problems.